All right, so today we're going to walk through our thinning assignment. We're going to build a few graphs. We're going to use a little bit of Excel. And what's important is that you used your time in the field in the last 2 weeks and your columnar paper properly. Remember what we talked about, using it as a pseudo-periodic table. That is to say, the diameters in the center, and then on the corners you have whether it would stay or go in certain cuts, right? So you would say, oh, this is a 6-inch tree in the center, and it's going to leave in a free thinning, or it's going to leave in a row thinning, or something like that. Something to indicate which trees leave or go, depending on which thinning you're talking about. So, the essence of what we're going to do is pretty much add up each tree in each DBH class, and then display that in our tables and figures. So we're going to start by looking at what we're going to shoot for, which is this. Dr. Clatterbuck sent this to you, should be in your email, or I have sent it to you. So this is an example of some tables and figures from previous years. Again, this is just an example. Don't, just copy it because it'll be wrong. This only has 3 thinning methods, and you have 4, for instance. But we can use it as a pretty good guide. So we can see across the top, we have our diameter classes, 1-inch diameter classes, which is what we used as well. We have across the left side, the spine, we have the unthinned stand, which is just the base stand values, as well as all the thinning methods. There's 4 of those. And then we also have our basal area here. We have our basal area, we have our diameter, our mean diameter, and we have our volume. And what this person has done is decided that they are going to do the removed as one, and then the post forest as another, and split those values up so you can see the difference. Additionally, if we flip this guy, we can see the figures that we'll make as well. So these are, again, inch diameter classes. And it's essentially this is presented on per acre basis. So was the table above. We're going to learn how to make these as well, so don't fret. Alrighty, so let's go ahead and move into Excel here. So the first thing we're going to look at, this is already filled out for you, so I'm going to walk you through it. But I'm going to tell you how to make it, but I've already done it. So what you would do is start off with your inch classes. You're going to look at your columnar paper and you're going to say, okay, what's my smallest tree diameter? What's my largest tree diameter, right? From there, you're going to count how many trees occur in your stand in each diameter class. So you're going to look at your columnar paper and you're going to say, I have, in this example, 12 5-inch trees. I have 8 6-inch trees, 10 7-inch trees, right? I've gone ahead and just added all those numbers together. This will give you the sum on a per stand basis. Now remember, our stand is 1/5 acre, but we don't report values in 1/5 acre. We report them on per acre basis. So 180 times 5 to get per acre basis gives us 400. And that's essentially what's happening here, right? That we've converted all the way to trees per acre. We've taken this value, multiplied it by 5, and that gives you that. If you want to quickly fill in tables, that's how you do it. So you click on a square, bottom right hand, wait till it turns that dark black thick square, and drag it over. So that's how you get trees per acre. So in my example stand, completely made up data, none of it's real, I have 400 trees per acre. This is the basal area of my stand. Now, if you look back at the thinning assignment, So that's going to be here. So this is your thinning assignment. We can go here. Now this is basal area. This is how to figure out basal area of one tree at one diameter. Okay, so basal area is equal to this number, which is known as the Forester's constant, multiplied by the diameter of the tree squared. Okay, so essentially how we're going to treat this is just typing in that equation. You can see the blue corresponds to the blue here, and the red is the red here. What's happening is we have the Forester's constant, right, multiplied by the diameter squared, okay? And that would give you the value of the basal area for one tree in each diameter class, or in that particular diameter class. Then what I've gone ahead and done is multiplied it by the count, how many trees I had in my 5th acre stand, and that gives me 1.6 basal area for the 5-inch stand, for the 5-inch trees within my 1/5 acre stand. You can bring that into a per acre basis by multiplying it by trees per acre. Remember? So Forester's constant multiplied by the fifth diameter class, right? Multiplied by trees per acre. Okay. Get rid of that and revert that. Okie doke. So I have 8.1 basal area for the 5-inch diameter class. And I've summed all of that together. Essentially, sum is a function. You type equals sum, and then you highlight all the cells you want to add together. So it prevents you from having to add each number to itself over and over. You just click and drag. To do that, you go equals sum. Click on it. Drag. Enter. 176 is our basal area per acre. Okay, we figured that out. Now this is for our base stand. Now we need to figure out average DBH, which is what I've done here. If you're a real tactile visual learner kind of person, this might make some sense to you. So I have the inch classes here. I've essentially taken them like this, copy and paste. That's all it is. And then in my head, I said, okay, well, I need to have 12 5s, right? Which is the count here, 12. That's how many 5-inch trees I had in my 5th acre plot. And what I've done is I said, okay, well, 13 is the maximum number of trees for any inch class. So I wrote 1 through 13 here, and I dragged that 5 like that, because that's 12 5s. Here are 8 6s, right? This will be 7 10s. Okay? Then you can use a function equals average this entire array of data, and it'll give you 8.65. That's the average diameter of a tree in this stand, which makes sense, right? It's about here. You know, we're pretty heavily loaded on 11 and 12-inch trees. We have 13 of each of them, so makes sense. If you want to be more abstract and quick about it, what you can do is, and you can do this based on the count, on the 1/5 acre plot. That's how I've done it. You can do it on the trees per acre. You'll get the same number because the mean won't change, right? Because you're still going to divide it by trees per acre or trees per stand. So that's what's happening here. We're multiplying 5 by 12, which is the same thing that's going on here. We're doing that for all of our inch classes. And then down here, we are summing all of those together, okay, and then dividing by the number of trees in our stand, okay, so in my case 80, and that gives me 8.65 as well. These are the same thing, right? They're both 8.65, just different ways of calculating the number. You could, right, so here I'm working on on the 5-inch class and trees per stand. You can do it on trees per acre as well. You just need to change this value to that value, okay? You can do it either way, but that's how you do it. Now, we need to figure out volume, and that's what's happening here. So I've imported my inch class and count, just take it from here and paste it here, right? Then I found volume factors. Now, these are in your thinning lab. So go up in your thinning lab to the volume section. So we're using total tree height here. And what I've done is, in my example data, I've set my total height at 55 feet for my trees. So 1.7 cubic feet in a 55-foot tree, that is 5 inches. Okay? And then I've just essentially done that here. I've pasted that number here, right? So 1.7, 3.3, 5.0, right? You can see that 5.0 right there. I've just done that for each inch class, okay? If I were you, I would probably use something like the total height average that you got on the trees with your clinometer. I've converted out to trees per acre, and now I can find volume per acre by multiplying by the volume factor, how much cubic feet is in one tree for one inch class, in this case the 5-inch class, multiplied by trees per acre. And that gives me total volume right here. And now I can just sum all of that together, and I know how much volume I have in my stand. This is stand basis because we've converted to acre, or sorry, this is acre basis because we converted to per acre volumes here, right? Now, that's just the base. That's how you know where you're starting from. Now we need to do all the thinnings. So, in our low thinning here, this is essentially the same thing. So let's look here and let's zoom in a little bit. Okie doke. So what's happening here is I have my inch classes just like I had before, and then I have my cut count. What I've decided here is that I am going to count the number of trees in each inch class that I'm going to cut. Now, this could have been done for any number of reasons that conform with each of your thinning methods. In this case, we're doing a low thinning. So I took out pretty much every tree that's in the lower inch classes. This generally conforms to trees that are smaller. And then you can see here, I have a few extra trees in each inch class. Maybe things like forked trees or bad form, or they were wiggly, any spacing even, but you need to make sure that it conforms to the what the thinning lab says each thinning is for, right? So let's look here. In your thinning, we can see that we have our low thinning here, our free thinning here, mechanical row, and row combo, right? So in our low thinning, we're removing low thinning trees, and we're removing trees in our lower crown classes, which generally correspond to the trees with the lower diameters, as well as trees with forks and cankers and cracks and sweeps and anything else, right? Even trees that have low live crown ratios. The remaining trees should be in the overstory. Great. So every time you're doing your thinning, make sure you're looking at this to make sure that you're following within those parameters. Alrighty. So this is my cut count. Remember, this is the number of trees that I have decided to cut out of my stand. You can import this function from the base stand. It's the same one, and the same thing happens here. What's important to know here, the way that I'm calculating basal area at this point is the same, but remember what these numbers represent, right? These are the number of trees I'm taking out of my stand. So when I sum them here together, this is the number of trees, this is the basal area on a per acre basis of the trees I am removing, not what is left. If we want to know that, we need to subtract it from the original basal area, which we end up doing later, essentially here. Right. So just understand what the numbers represent. We figure out average DBH again, doing the same thing. It's 6.8. And we do it the opposite way, right? We do it the way we did before, which is 5 times 12, times the cut, or times the number of trees we're going to cut in our stand. And that still gives us 6.8. Now, this is important. This is the original, right? So what I've done here is I've gone back to my base data. I've got these values and I've pasted them in here. So that's where all these come from. And then I've subtracted one from the other. Okay, so 60 from 60 leaves me with 0 trees. 48 from 48 leaves me with 0. What's happening here is I'm finding the residuals, what is left on the stand after I've cut it. And then I'm adding all those together and dividing it by the, this is base data K3 minus this K3. So what that means is it's a formula that works on multiple sheets, essentially. So I've the value for K3 here. If we look back at base data here, we can see K3, 80, right? And we're subtracting that from K3 here, 30, right? And what's happening is we're adding all these together, and then this is the number of trees we're dividing it by. You can see all the formulas in here if you'd like, but that's pretty much how it works. What this ends up with is 9.76 inches is the average DBH of a tree that we are leaving on the stand. So think about that on a broader picture. You can check your answer essentially by saying, well, what was my average DBH to begin with? 8.6. This is a low thinning, so I'm mostly taking out trees on the lower DBH class, so I can expect my average DBH to be lower for the trees I'm removing, right? These are all trees I'm removing, whereas what will be left, in that case, should likely be higher than what I began with, 8.6, right? So just think about it conceptually, and I think you'll be fine. What's happening here is the same thing, right? We are looking at the volume of trees we're removing and the volume of trees that are remaining. Okay, so what I've done is take my cut counts from here, imported them right there. Volume factors are still the same. Trees per acre is this number multiplied by 5, right, to get trees per acre. And then volume per acre is volume factor multiplied by trees per acre, the sum being the total. We're kind of doing the same thing here that we did earlier. We're saying this is the base count. I imported this from the base data here, right? So these are the same values. These are the cut count. I got that from here, the top cut count. And then the residuals are what's left, right? Just subtraction. That's it. Subtract 12 from 12, get 0. Subtract, 2 from 10, get 8. So our cut trees per acre is essentially how many trees we're cutting per acre in each inch class. So this is the 5-inch class, this is the 6-inch class. So we're cutting 60 5-inch trees. We're taking our cut basal area, which we already calculated up here, right? Cut basal area for each inch class. We're bringing that down here. We're grabbing our basal area trees per acre from the original. So this is base data. And we're finding out the residual basal area per acre. So, again, what's happening is we're taking our cut values, cut trees per acre, and cut basal area, and our base trees per acre, and our base basal area, and we're subtracting the basal areas from one another, right? So 8.1 minus 8.1 is 0. 2.6 minus 13, is 10.6. And what's happening here is we're essentially subtracting these two greater values. This is the sum of all of these numbers here, and this is the sum of all of these numbers here, and we're subtracting them from one another. So we can see that after our low thinning, our residual is 134 basal area, right? And that's because we removed 42 basal area from 176 basal area. And what's essentially going to happen is you're going to do this for each thinning method, right? So here's my free thinning method, here's my row thinning method, and here's my combo row and free thinning method. So we can walk through these because they are a little different. You can see here we're taking out a lot more just trees, especially from the higher the higher inch classes, which means we're also taking a lot more basal area. Now, if you look at your sheet, it'll say goal is to get down to around 80 basal area. You can see that here. This is 176, which is about the starting basal area, our base basal area, subtracted from our total basal area that we're removing here. Remember, this is removed trees that we're taking out, because the cut count is how many trees in each inch class we're taking out. So we're again figuring out average DBH both ways, so 7.8. And we're doing it the other way, which is inch class multiplied by cut count, and then that all summed, right? All the cut count times diameter classes summed divided by the total number of trees that we're removing. So that gives us 7.82 as the average diameter of the trees that we are removing, whereas the trees that are remaining are residuals. The average DBH is 10, which again makes sense, right? We can see that here our average DBH for our free thinning is a little lower because we're prioritizing taking out more of the lower inch classes. Here we're taking out some of the lower inch classes as well as some of the higher inch classes. which means we get a higher average DBH of trees we're removing overall. Okay. Volumes, pretty much the exact same way as far as calculating. Volume factor multiplied by trees per acre gives you how many cubic feet you are removing in each diameter class. Sum all of that together, and you get the total volume you are removing in your cut. This is how many trees are left, your residuals, right? So we have cut trees. Now remember where we got that from up here. Converted to trees per acre. Our cut basal area, right? Our base trees per acre and our base basal area, which we got from the base sheet earlier, and then subtracting those from one another to find residual basal area per inch class, right? And that leaves us with 85 basal area in our stand after we've cut. Because we started out with 176, we're removing 91 basal area, and we get 85 basal area. Row thinning, pretty similar, same process as well, but the average DBHs are going to be a little more smooth because you're taking out the average, right? You're taking out essentially the same number of trees, 33% of the trees. So there's no favorability for the high inch DBH classes and no favorability for the low inch DBH classes. What I've done is essentially divided my cut count by 1/3, and that's how you get the values here. You should not do that. You should look at your columnar paper and count the number of trees in each of the diameter classes that are in those columns, in those rows, rather, and put those whole values in your cut count. Now remember, don't choose a row on the ends. Choose rows in the center. So, row 2, row 5, something like that. Row 3, row 6, something like that. And all of this is the same. Trees per acre, basal area. We get left with 118 basal area because we're taking out 58. Great. Wonderful. Diameter is the same. Now, this is a little different because I had to use whole numbers here to get the average function, right? But your average DBH should be very similar to your base DBH here, because you're taking out 1/3 of the trees. There's no favorability, again, for the high or the low, so having an 8-inch and 8.6 DBH makes sense when your average DBH is 8.6. So that's something to remember. It's the same for the trees you're cutting as well as the residuals in my case, because I divided everything by 0.33. So moving on to our volumes. Volumes are calculated the same way. Trees per acre multiplied by volume factor gives you volume. Sum all of that together gives you the volume you're removing, right? And you can subtract that from the base volume to figure out how much volume is left. You could also calculate it the other way. You can find the trees per acre in the residual, right, and multiply that by the volume factor, sum all of those together, and you'll get the inverse, which is the residual volume that you're leaving in the stand. This is essentially telling you how many of each of the residuals will be left. Again, here we have the figuring out the basal area, right? Residual basal area and cut basal area, which is the same thing. We've already seen it. Subtract base basal area from cut basal area, add all of them together, and then you get a value like 118 or essentially 1/3 of the original, sorry, 2/3 of the original basal area will be left in the stand. And then we have our combo, which is our row thinning plus our free thinning, right? So we have, these are again made up values, but they should be pretty close. I've prioritized taking out trees in the lower inch classes because that's what I took out in my free thinning. I've calculated basal area here again. When you sum all of these together, and then you subtract that from 176, which is my starting basal area, my base basal area, I'm left with about 78 basal area on my stand. Again, calculating average DBH the same kind of way. Diameter count, pretty much the same, calculating it all the same way. Again, summing that all together, dividing it by K3. K3 in this case is the total cut count, the number of trees that I am cutting in my stand. And then this is, of course, the opposite. This is finding the average DBH of the residuals, which in this case is 10 inches. And then we're doing the same thing. Volumes are calculated the same way. Calculating residual basal area is all the same that we've seen before. Now, let's move to charts and figures. So, I have essentially modeled this chart off of the one that we saw earlier. That being this guy, right? It's rotated, but it's the same thing. So, I have my diameter classes across the top, and I have my cutting methods across the side here. I have basal area, mean diameter, cubic feet volume, and trees per acre. Again, all of these values are reported on a per acre basis, right? Because we don't report things in per stand basis, it's per acre basis. So I've added trees per acre, which was not on the original one, but it's very simple. So what's happening here is this is a function that calls to another sheet. So in this case, the way you do it is by equals, go to that sheet. In this case, basal area. We're looking for basal area of the base stand. And that's going to be in K6. There. Ta-da. 176. Now it's here. Mean diameter, it's the same thing, right? Equals, go to the sheet, click on the mean diameter. We've already calculated it. Cubic feet volume works the same way. Trees per acre works the same way. Go to the sheet, click on the cell, it'll appear here. Use the enter to make it a function. Remember that. I have just pasted in the values for each of the diameter classes. Remember, those are across the top left in each of our sheets. And we have, I have the removed as well as the post. So what I'm saying here is I have the values for both the, let me explain. This value, this 60, is coming from low thinning, right? Trees per acre in the 5-inch class. I have imported that over here. I've imported all these values here, and I've simply subtracted the 60 from the 60, the 40 from the 40, the 50 from the 10, the da-da-da-da-da, all the way down. And that's how I have the post low. That is to say, the residual low. You can call it residual if you like. So I have the removed low thinning as well as the post low thinning. So these are essentially the same coin. They're two sides of the same coin. So the basal area here is essentially that subtracted from that, right? The basal area we're removing from the original basal area gets us to the basal area that will be left. Now, if you want to check that value, we already calculated basal area earlier. You can go back to your sheet and check it. Or you can even just import that, like I've done here. which is going to the low thinning sheet and clicking on the mean diameter of the post low thinning. Remember, that would be here, 9.76, 9.76. Same with the cubic volume, except in this case, it's subtracted. Trees per acre can also be found out by just subtracting the trees that you're removing from the trees that you had originally. Again, if you want to verify that number, you can go back to your sheet, add up all the trees you're counting, add up all the trees you're removing, and subtract that from all the trees that you had at the beginning, and that's how you do it. Now, that continues for each of these. They're all the same. They're just pulling values from different sheets, but they're all pretty much the exact same, so if you know how to do one, you know how to do all the rest of them. What I've done here is essentially compressed this data. So I've taken all of these and I've pasted them here, and then what I've done is grabbed the removed trees, the trees we're going to remove, and pasted them here. Sorry, the post trees, and pasted them here. And so if we go to our free thinning and we look here, this should be post free thinning 0, 0. Wonderful. So I just take all the post values and paste them in for each of the thinning methods. And this is how I've made my charts. So, for instance, in order to get my low thinning chart, I highlight all the values I'd like. I go to line graphs and I just pick the line graph. You can make this kind of a chart by inserting a stacked 2D line area. Do not choose stacked area. These are just area. Okay? That's how you make this chart. Either way, that's how you make the chart. Insert line, either choose 2D line here or 2D area, and it'll provide that for you. Now, always axis titles. If your axis, this is inch classes, this is trees per acre. Give it a title, right? So we know that this is the low thinning and the base versus the base stand, or whatever it is. If this value is not correct here, make sure that this is in inches. Sometimes it can just decide that this is 1 through 7, or however many inch classes you have, and you may need to affect that somehow. So that would be in select data, and you can see it's selecting this guy here, and you can change the axis labels just by clicking and dragging on that. So if you have that problem, that's how you fix it. You're going to continue to do that. Let me show you a trick here. You can grab that, control, highlight something else, right? So this is my row combo. Make a line chart, right? So you can highlight multiple cells by doing things like that with separations. If you don't want separations, say you want to make it the whole thing, you can choose to do that, just highlighting it, or you can hold down the shift key and highlight the whole thing, essentially clicking there, hold shift, click there, it'll highlight the whole thing, and that's how you would make a chart with every line on it, but that's a little messy. So if I'm advising you, make a chart for each of the different thinning methods. So here's pretty much all 4 of my thinning methods. Here, my low thinning, my free thinning, my row combo, and my row thinning. So give them all chart titles. If you'd like to do an area chart like this one, feel free to. You can change the colors by changing the fill and the outline. You can also change the line width, but that's pretty much how you make everything. That's how you do the whole thing. I will try to provide you this Excel document for your use. Please, please, please try to do this on your own. Try to make your own Excel sheet by following this Excel sheet. Try not to just paste values from mine or formulas from mine, because I want you to learn how to use Excel. I guarantee you it'll be very important in your future career, regardless of whether it's in wildlife or forestry or fisheries or just a desk job, anything like that. So, thank you for watching. Appreciate it.